For most of human history, people have asked a simple question about the universe. Where did everything come from? Look around you. Every object has a cause. Every event has a beginning. A star forms from collapsing gas. A tree grows from a seed. Even human lives follow a clear path from birth to death. So it seems natural to assume the universe must also have begun at some point. A first moment. A beginning of everything. For the past century, modern science appeared to confirm this idea. According to cosmology, the universe began about 13.8 billion years ago in an event known as the Big Bang. Space expanded from an extremely hot and dense state. Matter formed, galaxies emerged, stars ignited. From that moment onward, the universe evolved into the vast cosmic structure we observe today. But there is something deeply strange about this explanation. Because when scientists tried to understand the Big Bang more deeply, they encountered a problem. A problem that challenges the very idea of a beginning. What if the universe never actually began? What if the first moment we imagine never existed? To understand this possibility, we need to rethink something we usually take for granted: time itself. In everyday life, time feels simple and obvious. There is the past events that already happened. There is the present, the moment we experience right now. And there is the future, everything that has not yet occurred. This flow seems fundamental to reality. Time moves forward, carrying the universe with it. But modern physics suggests something very different. According to Einstein's theory of relativity, time is not a universal clock ticking the same everywhere. Instead, time is woven together with space into a single structure known as spacetime. In this framework, the past, present, and future are not separate layers that appear one after another. They are part of the same four-dimensional structure. Imagine a film reel. Every frame of the movie already exists on the strip. The beginning, the middle, and the end are all there simultaneously. When we watch the movie, we experience the frames one by one, giving the illusion of motion and change. But the film itself already contains the entire story. Some physicists believe reality may work in a similar way. All moments in time could exist together within the structure of space-time. If this is true, the universe may not be something that moves from the past into the future. Instead, time may simply be another dimension of reality. And this idea leads to a strange possibility. If all moments exist within the structure of space-time, then the universe might not need a beginning at all. The concept of a first moment may only exist from our limited perspective inside time. But there is an even deeper reason scientists question the idea of a cosmic beginning. And it comes from the physics of the Big Bang itself. When we look back in time using powerful telescopes, we see galaxies moving away from us in every direction. This observation reveals that space itself is expanding. If we reverse this expansion mathematically, everything converges toward a single extremely dense state in the distant past. This is what we call the Big Bang. But here is the problem. The equations describing gravity break down at that point. When the universe becomes infinitely dense, our current theories stop working. This breakdown is known as a singularity. A singularity is not necessarily a real physical object. Instead, it often signals that our theories are incomplete. It is like reaching the edge of a map where the cartographer simply wrote, "unknown territory." In other words, the Big Bang singularity might not represent the true beginning of the universe. It might only mark the limit of our current understanding. To go further back, we need a theory that combines gravity with quantum physics. And when physicists explore this deeper level of reality, new possibilities begin to appear. One of the most fascinating ideas is that the Big Bang was not a beginning at all. Instead, it may have been a transition, a moment when the universe changed from one state to another. Some theories propose that before the Big Bang, the universe was actually contracting. Over immense periods of time, the cosmos may have slowly collapsed inward. Then, when it reached an extremely dense state, quantum effects prevented it from collapsing into a singularity. Instead of ending, the universe bounced. This idea is known as the Big Bounce. In this scenario, the Big Bang was not the birth of the universe. It was the rebound of a previous cosmic phase. Another possibility comes from the concept of eternal inflation. In this model, space itself undergoes continuous expansion driven by quantum energy. Small regions of this expanding space occasionally stabilize and form universes like ours. Our Big Bang may simply be the birth of one region within a much larger cosmic system. If this is true, the process of universe creation could be happening endlessly. new universes emerging within a vast, eternal cosmic landscape. In such a scenario, asking when the universe began might be like asking when the ocean began producing waves. The waves have beginnings and endings, but the ocean itself may have always existed. Some physicists go even further. They suggest that time itself might not be fundamental. At the deepest level of reality, time may not exist at all. Instead, the universe might be described by timeless mathematical relationships. In certain approaches to quantum gravity, the fundamental equations do not contain time as a variable. They simply describe how different configurations of the universe relate to one another. Time, in this view, emerges from the relationships between physical systems. It is something that appears only when complex structures exist, like temperature emerging from the motion of countless atoms. If time is not fundamental, the idea of a first moment becomes difficult to define. After all, how can something begin if time itself does not exist yet? The concept of a beginning requires a timeline. But if time emerges from deeper physical processes, the universe may exist beyond the concept of before and after. This possibility challenges one of the most deeply rooted assumptions in human thinking. We are used to explaining things through causes. Every event has something that came before it. But the universe as a whole may not follow this rule, because causality itself depends on time. If time is not fundamental, cause and effect may not apply in the way we expect. Reality might simply exist as a complete structure, a system where all events are part of a larger pattern rather than a chain of causes. This idea can feel deeply unsettling. Our minds are built to search for origins. We want a first explanation, a moment when everything began. But nature does not always follow the logic that feels intuitive to us. In fact, many discoveries in physics have shown that reality is far stranger than everyday experience suggests. Quantum mechanics reveals a world where particles behave like waves, where events happen with probabilities rather than certainty, where observation itself influences physical outcomes. Relativity shows that time slows down near massive objects and at high speeds. Two observers moving differently can disagree about the order of events. These discoveries already force us to abandon many common assumptions about reality. The nature of time may be another illusion waiting to be uncovered. And if time itself is not fundamental, then the universe may not need a beginning. Instead of emerging from nothing, reality may simply exist as a timeless structure. But this idea raises another profound question. If the universe has no beginning, why does anything exist at all? Why is there a universe rather than nothing? This question has puzzled philosophers and scientists for centuries, and even the most advanced theories of physics may not provide a complete answer. Some physicists argue that nothingness may not be stable. Quantum physics suggests that empty space is not truly empty. Even in a vacuum, quantum fluctuations constantly create and destroy tiny particles. If this principle applies to the entire universe, existence might arise naturally from the laws of physics. Others believe the question itself may be flawed. Perhaps asking why the universe exists is like asking why mathematics exists. Some things may simply be fundamental aspects of reality. They do not require further explanation. Another possibility is that our universe is only one part of a much larger multiverse. Different universes could exist with different physical laws. In that case, our universe might not require a unique explanation. It could simply be one realization among many possible realities. Yet even these ideas do not fully resolve the mystery, because they shift the question to a deeper level. Why does the multiverse exist? Why do the laws of physics exist at all? At some point, explanations may reach a boundary beyond which we cannot go. Not because reality has an edge, but because our understanding does. Still, the exploration itself reveals something remarkable. The universe is not just vast in space, it is vast in mystery. Each new discovery opens deeper questions about the nature of existence. And sometimes the answers challenge the most basic assumptions we have about reality. For centuries, humans believed time flowed the same everywhere. Relativity proved otherwise. For centuries, humans believed matter was solid and continuous. Quantum physics revealed a world of probabilities and uncertainty. Now, modern physics hints that time itself may not be fundamental. And if that is true, the universe may not have a beginning. What we call the Big Bang may simply be the earliest moment we can currently observe, not the first moment that ever existed. Reality may extend far beyond the limits of our current theories. And perhaps one day, a deeper understanding of quantum gravity will reveal the true nature of time. It may show whether the universe truly began, or whether it has always existed in some form beyond our imagination. Until then, the mystery remains. But sometimes the most powerful discoveries begin with a simple question. What if the universe has no beginning? Because if the universe never truly began, then reality may be far stranger than we ever imagined.